Okay, topic 5.7 electromagnetic wave. Okay, so what is electromagnetic wave? Okay, first we want to look at characteristics of electromagnetic wave. So electromagnetic waves are made up of an electric field and magnetic field that oscillate perpendicularly to one another. So you can see from this diagram, okay, you can see from this diagram. So this is magnetic field. You see this blue color one is magnetic field. So the magnetic field oscillate up and down, okay. Okay, this one is downward, this one is going up, this one is down, this one is up, down, up. Okay, so this is the oscillation, direction of oscillation of magnetic field. Next is the electric field. Okay, you see the electric field. The direction of oscillation of electric field is to the right, to the left, to the right, to the left, to the right, to the left. So you see the direction of oscillation of the electric field is perpendicular with the magnetic field, 90 degree. Okay, this is 90 degree. This is 90 degree. Okay, this is 90 degree. You see now? Okay, electric field and magnetic field, they oscillate perpendicularly to one another. Okay, that means they oscillate at 90 degree to one another. Okay. Okay. So electromagnetic waves are transverse wave. Okay, they are transverse. And why is it that we say it is a transverse wave? Because the direction of oscillation is perpendicular with direction of propagation. You see, this is direction of propagation. This is direction of propagation. And you see the direction of oscillation. Don't care whether it is the magnetic field. You see the direction of oscillation of magnetic field is perpendicular with the direction of propagation. The direction of oscillation of electric field also perpendicular with the direction of propagation. So electric field and magnetic field, they oscillate perpendicularly to one another, and both of them oscillate perpendicularly with direction of propagation. So that means it is a transverse wave, because transverse waves are waves where the direction of oscillation is perpendicular with the direction of propagation. Okay. Alright, so why like that? Okay, I want to explain a bit why like that. Why does it oscillate like that? Okay, previously in form, I think in form 2, you got learn about electric charge. Okay, you got learn a little bit about electric charge. You learn that let's say that we have an electron. Okay, electron have electric charge around the electron. Okay, we can use lines to describe the. Okay, we use lines to. Okay, we use electric field lines. Okay, electric field lines. Okay, electric field lines. Okay, these are electric field lines. To help us visualize what do the electric field looks like. Okay, this is something that you learn a little bit lah. Okay, you will learn a little bit in, I think in form 2 lah. Okay, in form 2. Okay, now, so these electric field lines, they extend to infinity. That means it go on and on and on and on. Okay, to infinity, continuous. Okay, that means all of them lah. All right. So when this electron, let's say with this electron, when this electron oscillate up, down, up, down, up, down, up, down, what will happen to these electric field lines? What will happen to the electric field? The electric field will oscillate lah. Up, down, up, down, up, down. So this is the direction of propagation. And this is the direction of oscillation. You see, direction of oscillation is perpendicular with direction of propagation. So this is transverse wave lah, right? But how about, this is only the electric field, oscillating electric field. But how about the magnetic field? How about the magnetic component? This is the electric component. How about the magnetic component? Because we are talking about electromagnetic wave, right? Okay, electromagnetic wave. So what happened to the magnetic component? Also in, I think also in Form 2, okay, also in Form 2, we learned that if we have a wire, and in this wire we have electric current. Around this wire, we will have magnetic field. Right? Okay, magnetic field will be produced around a conductor that carry current. Okay, I repeat. If we have a conductor that carry current, that means got electric current flowing inside the conductor, then around the conductor will have magnetic field. Okay, this is a natural phenomenon. When we have electric current, the electric current will produce magnetic field. And what is electric current? Electric current is the rate of flow of charge. That means if we have a charged particle that flow, then we will have electric current. Okay, we will have electric current if we have charge that is flowing. And when we say charge that are flowing, that means things like electron, because electron have charge, and when we have electric current, the electrons are flowing, the charge are flowing, the electrons are flowing, moving inside the conductor. So that means as long as we have moving charge, moving electron, that means along the path where the electron move, there will be magnetic field. That means if we have one electron move in this direction, then that means around this path of where the electron flow, there will be magnetic field. Okay, there will be magnetic field that are produced. Okay, now when and also in Form 2, you also learn that the magnetic field have direction. Okay, the magnetic field have direction. And how is it that we can find out the direction of the magnetic field? By using right hand grip rule. That means if we put our right hand, okay, and we make our fingers we grip like this, our finger we grip like this, then this thumb is direction of current, and this direction of finger is direction of magnetic field. Okay, direction of the thumb is direction of current, direction of the finger is direction of magnetic field. So that means if the current moves like this going up, so that means the magnetic field is in this direction. Okay, this is the direction of the magnetic field. And of course, if the current change direction, that means the magnetic field also change direction. So now we look back at this electron. This electron oscillate up, down, up, down, up, down. That means we have charge that is moving, which is the electron. Okay, the electron have charge, and when the electron moves, that means charge is moving. And when charge is moving, that means we have electric current. And when we have electric current, around the path of the electric current, we have magnetic field that is produced. Okay, we have magnetic field. And because this electron keep on oscillating, going up and down, up and down, up and down, that means the direction of current keep on changing, up and down, up and down, up and down. And if the direction of current keep on changing, that means the direction of magnetic field also keep on changing. And you see the direction of the magnetic field. This is direction of current. This is direction of magnetic field. You see or not? Okay, the magnetic field like this. So that means the magnetic field, okay, the magnetic field and the current is perpendicular. Okay, perpendicular 90 degrees with each other. So that means the magnetic field will be like this. Because why the magnetic field oscillating? Because the magnetic field keep on changing direction. Okay, magnetic field keep on changing direction. Okay, get the idea? So that means if we have one electron that is oscillating, that means we will have electromagnetic wave. Okay, every time we have electron or other charged particle, any charged particle, ions and so on, if we can make it oscillate, vibrate, okay, vibrate, oscillate, move around, then all that vibration will produce electromagnetic wave. Okay, it will produce electromagnetic wave. Okay, get the idea? Get the idea of how is it that the electromagnetic wave is produced. And when we understand how the electromagnetic wave is produced, we will understand that the reason why the electric field and magnetic field is perpendicular to each other, and we will also understand why the direction of oscillation is perpendicular with direction of propagation. And if we know all of this, that means automatically we will know that electromagnetic wave is a transverse wave. Okay, right. Okay. Okay, now we go back to here. We want to look at all the other characteristics of electromagnetic wave. Okay, so just now we say that electromagnetic wave are transverse waves. So we already discussed why is it a transverse wave. And next, electromagnetic wave do not need medium for propagation. When we say no need medium, that means it doesn't need a gas, a solid, liquid or gas. Doesn't need matter to propagate, not like water. Water wave only propagate in water. Sound wave, it needs particle to transfer the vibration, transfer the energy. So sound wave need solid, liquid or gas in order for the sound wave to propagate. But electromagnetic wave, what is electromagnetic wave? Electromagnetic wave are oscillating electric field and magnetic field. So electric field and magnetic field, they extend to infinity. That means go all the way in space. That means it is not a matter, okay? It doesn't need matter to transfer the energy in the electromagnetic wave, okay? Alright, so electromagnetic wave, no need medium for propagation. Okay, electromagnetic wave can propagate through vacuum. Because no need medium, right? So that means it can propagate through vacuum. And have speed in vacuum. The speed in vacuum is c, the symbol of speed of light. Okay, the symbol for speed of light is a small c, is 3 times 10 power by 8 meter per second. So this 3 times 10 power by 8 meter per second is the speed of electromagnetic wave in vacuum, and move with lower speed in any medium. That means when the electromagnetic wave when it travel through when it propagate through matter, that means propagate through gas, propagate through liquid, propagate through solid, then the speed will become lower. Okay, so the maximum speed of the electromagnetic wave is 3 times 10 power by 8 meter per second. So why is it that this 3 times 10 power by 8 meter per second, we call it the speed of light? Because this is the speed of light, and light is actually electromagnetic wave also. Okay, light is also electromagnetic wave. Okay, so next, okay, show phenomena of reflection, refraction, diffraction, and interference under suitable condition. Okay, so electromagnetic wave is a wave, so of course it can act like a wave. All wave, don't care what kind of wave, don't care if sound wave, water wave, electromagnetic wave. Okay, all the wave can show phenomena of reflection, refraction, diffraction, interference. Okay, they can show all of these characteristic of, okay, they can show the phenomena, wave phenomena. Okay, all wave have wave phenomena. Okay, all right. Okay, so these are the characteristics of electromagnetic wave. Okay, these characteristics are very important. Make sure that you remember all of them. All of them you must remember. Okay, you must remember all of them. Okay. Alright, so next we want to look at electromagnetic spectrum. Okay, what is electromagnetic spectrum? Okay, so there are 7 types of electromagnetic wave form a continuous spectrum known as electromagnetic spectrum. So this is the electromagnetic spectrum. Okay, so electromagnetic spectrum from the gamma ray until radio wave. Okay, there are 7 types of electromagnetic wave. So all of them combined together, we call it the electromagnetic spectrum. Okay, so what does it mean by continuous spectrum? Continuous spectrum, that means no specific boundary which separate two adjacent type of wave. That means the radio wave and microwave, the boundary, that means the border is vague. Okay, very vague. That means the radio wave, the frequency of radio wave changes, and then suddenly it's already microwave. Okay, that means we don't have like a certain frequency. Okay, 10 power by 9 hertz is radio wave, and when it become okay, for example, 1,000,000,000 hertz is radio wave, and when it is 1,000,000,000,001 hertz, and then suddenly it become microwave. Not like that, okay, not like that. That means it's slowly, and then change to go into microwave like that. Okay, so that is what it means by continuous spectrum, and continuous spectrum also means that it can be any frequency, it can be any wavelength. Okay, that means there is infinite decimal for the frequency and infinite decimal for wavelength. That means the frequency can be 100.1 hertz or 100.11 hertz or 100.111111111111 hertz. Okay, there is infinite decimal for the frequency and wavelength. Okay, so that is what we call continuous spectrum lah. Okay. Okay, now, so this is very important. You look at this. You look at this diagram. Okay, you look at this diagram. Okay, so this diagram is the electromagnetic spectrum. So you see, first you look at this, the wavelength. Okay, here the wavelength is long. Okay, long wavelength or big lah. And then go over here, the wavelength becomes short. Okay, okay, wavelength. One side is long, one side is short. But when you look at the frequency, okay, you look at frequency, this side, the side where we have a long wavelength, the frequency is actually low frequency. And then on the side where we have short wavelength, we have high frequency. Why like that? Why is it that when the wavelength is longer, the frequency will be lower? You just look at the wave equation. You still remember wave equation? We got learned in topic 5.1, the fundamental of wave. We learned the wave equation, V equal F lambda. So the speed of electromagnetic wave is the speed of light. So that means this wave speed we replace with a symbol C that represents speed of light. So equals to F lambda. So the speed of the electromagnetic wave is fixed. And that means that if the wavelength increase, then the frequency will decrease, and vice versa, and that means in the opposite. That means if the wavelength is short, then the frequency will be high. Okay? Okay, So this is very important because usually a lot of students, they get confused with this. When the wavelength long, frequency is low. When the wavelength is short, frequency high. Okay, a lot of students, they get confused. Okay, because the wavelength and frequency, they are opposite each other. They are reciprocal of each other. Okay. All right. So that is the first thing about this electromagnetic spectrum. When if the wavelength of the electromagnetic wave is long, then the frequency will be low. Okay. All right. So we look at this electromagnetic spectrum from long wavelength. Okay, we look from long wavelength. Why is it we look from long wavelength? Because long wavelength, the frequency is low. So we start from low frequency and then we slowly get the frequency getting higher and higher. Okay, higher frequency, then we see what kind of wave. Okay, how do the wave transition? Okay, what is the transition of the type of electromagnetic wave? Okay, start with long wavelength or low frequency. We have radio wave first. Okay, we have radio wave. So radio wave is the wave that we have in our radio for telecommunication. Handphone also use radio wave. Okay, the Wi-Fi, Bluetooth, all of that, they are radio wave. Okay. Okay, so radio wave, television, all that Okay, walkie-talkie, radio wave. Okay, so as the wavelength get lower and lower, that means the frequency increase, the frequency getting higher and higher. That means the speed, how fast is the oscillation? Okay, the speed of oscillation getting faster and faster. Okay, then the radio wave will transition and go into microwave. That means when it reaches a certain frequency, then we start calling that electromagnetic wave as microwave. They are all electromagnetic wave, from radio wave until gamma ray, they are all electromagnetic wave, but we group them into different group lah. Okay, we group them into different groups. Some we group them into certain group because they have similar characteristic. Okay, due to similar characteristics, so we group them. Okay, radio wave. And then after that we have microwave. Okay, so microwave is like what this name say lah. Okay, it is a wave that is produced by your microwave oven. Okay, the microwave oven produce microwave. Okay, and microwave, where is it that we can find or apply microwave? We also use microwave for satellite communication. That means from ground to satellite, satellite to ground. Okay, we use microwave. And higher frequency, we go into infrared ray. Okay, infrared ray, higher frequency, then we will go into visible light. Visible light is the light that we can see. Okay, that our eyes, the cell, the light sensitive cell or the photoreceptor in our eyes are sensitive to this frequency or this wavelength. Okay, from 750 nanometer until 400 nanometer. So these are the wavelength that our eyes, that the cell in our eyes are sensitive to, can detect. Okay, so when it can detect this wavelength, then that means we can see we can see this electromagnetic wave. Okay, so we call it visible light. Okay, understand? Okay, so you see the visible light. Here the wavelength is long, and the long wavelength, the color is red color. You see, because the long wavelength is near to the infrared ray. Okay, near to the infrared ray, so it's red color. Or our brain interpret the impulse as red color, because color doesn't exist. Color is just something that our brain produce on its own. Our brain make it up, okay, to make us see color. Okay, actually it is all just electromagnetic wave. They are all the same. Okay, they are all electromagnetic wave, but different wavelength our brain interpret as different color. Okay, like that. So as the wavelength becomes shorter or the frequency become higher, the color slowly change from red to orange, yellow, green, light blue, blue and purple. Okay, going towards violet color. So blue color, violet or purple color, the wavelength is short. Okay, short wavelength and the frequency is higher. This one, the frequency is lower. And after the purple color or blue color, after blue, after violet, then it will become ultraviolet ray. When go into ultraviolet ray, then our eyes cannot see. Okay, we cannot see ultraviolet ray. Some animals can. Okay, some animal can see, especially insect. Insect can detect ultraviolet ray. Okay, ultraviolet ray. And then higher frequency, we have X-ray, and even higher frequency, then it becomes gamma ray. Okay, so these are the 7 type of electromagnetic wave, from radio wave, microwave, infrared, visible light, ultraviolet ray, X-ray, and then gamma ray. Okay, so these arrangements are very important. Okay, very important. You must memorize. Okay, you memorize the arrangement. you don't have to remember, oh, radio wave is until 10 power by 9 hertz, and then after that is microwave until 10 power by 11 or 10 power by 12 hertz, and then infrared. That means you don't need to care about the frequency or the wavelength of the type of wave. What you need to be able to do is to arrange, okay, the 7 type of electromagnetic wave in ascending order or descending order based on the wavelength or based on frequency. Question can ask, arrange the electromagnetic wave from in ascending order according to the wavelength. That means from short wavelength to long wavelength. Then you need to arrange X-ray, ultraviolet ray, visible light, infrared, microwave, radio wave, like that. Or if the question asks you to arrange in descending order according to the wavelength or according to frequency, then you arrange. Okay? Okay, so this is very important. All these 7 you must memorize. Okay, must remember, must memorize. All of them, the arrangement. Which one have longer wavelength, which one shorter wavelength, which one higher frequency, which one lower frequency, okay? And of course, the color. The color is easy to remember, okay? I believe everybody know the arrangement of the color of rainbow, right? Okay, so this is exactly the same as the arrangement of color for the rainbow. And the longer wavelength one is the one that near to the infrared. The shorter wavelength one is near to the ultraviolet ray. Okay? Okay, next. Okay, so the energy carried by electromagnetic wave is directly proportional to its frequency. That means the higher the frequency of the electromagnetic wave, the greater the amount of energy that is carried by the electromagnetic wave. Okay? So that means this electromagnetic wave, there are 2 ways that we can look at the amount of energy. First, we can look at the amplitude. Second, the higher amplitude have more energy, lower amplitude have less energy. Second is we look at the frequency. If the frequency is higher, then it carry more energy. Lower frequency carry less energy. That means the radio wave frequency low, so that means radio wave, the energy is low. Okay? Compared to gamma ray, the energy is the highest compared to all the other type of electromagnetic wave. Okay? Higher frequency, more energy in the electromagnetic wave. So this is also very logical because if higher frequency, that means the speed of oscillation is faster. If faster, that means more energy Okay, right? Faster, more energy. More energy, then we can oscillate faster, right? So high frequency, that means higher energy. Okay. Very logical, and that is also the reason why starting from ultraviolet ray until gamma ray, these electromagnetic wave they pose danger to us Okay, dangerous. Okay, dangerous. For example, ultraviolet ray UV, you always see in like advertisement or something, right? Okay, that say, okay, you wear these sunglasses, or you wear this use this umbrella or this tinted or something like that, and then it can block the UV, block ultraviolet ray. Okay, you go to the beach, you go swimming, you must put on the sunscreen lotion. Put the sunscreen lotion. Why? So that it can block the UV. Block the ultraviolet ray from the sun. So the reason why ultraviolet ray is dangerous is because it has high amount of energy lah. That is why if you are exposed to ultraviolet ray a lot, for example, you play sports under the sun, or you go swimming under the sun. Okay, you swim for a long time, so your skin is exposed to the sun for a long time. What is it that will happen is you get sunburn, right? Okay, you get sunburn. So the reason why you get sunburn, or your skin, the top layer of your skin become dye, your skin dye, is because it's killed by the ultraviolet ray. Okay, the ultraviolet ray kill the skin cell, the top layer, so become sunburn. Okay, that means the energy, the ultraviolet ray have a lot of energy, and when the ultraviolet ray hit your skin, okay, come into contact with your skin, and your skin will absorb the energy from the ultraviolet ray. When absorb the energy, then the temperature increase, the chemical reaction can happen, and too much energy, then your skin cell die. Okay, the skin cell will die, and then you get sunburn. Okay, for those of you, if you get sunburn before, then you know that it's very painful. Okay, if don't get sunburn, because if you get sunburn too many times, it is very dangerous. That means it can increase your risk of skin cancer. Okay, I repeat that it can increase the risk of skin cancer. So when you work under the sun, or play sports, swim under the sun, okay, under bright sunlight, make sure you wear the sun tank, or the sunscreen, okay, the lotion, okay, sunscreen lotion, or you wear long sleeve, wear hat, use umbrella, and so on, okay, to block the UV. Okay, all right. So of course, ultraviolet ray already can make your skin sunburn. X-ray, which have a higher frequency than UV, is even more dangerous. That is why you cannot take too many X-ray in one day. Okay, X-ray is just, when you go and take X-ray, is only you are only exposed to the X-ray for a very short time. Okay, taking X-ray is like taking picture right now. Okay, you just expose, you can hear a sound like that, and then that means the X-ray already passed through your body. You don't feel anything at all. Okay, so the exposure, when you take the X-ray photograph, your time of exposure to the X-ray is very short, okay, very short. So you don't have to worry, but there is a limit number of time when you can take X-ray. One day you can take how many X-ray? There is a limit, If you take too many times, then it's very dangerous. Okay, so unless it's emergency, then the doctor will not ask you to take more than 2 X-ray in one day. Okay, unless it's really necessary to save your life. If not, the doctor will not ask you to take multiple X-ray in one day. Okay, and so after X-ray is gamma ray. So gamma ray is even more dangerous, and like what we learn in Form 3, you got learn about radioactivity, right? Okay, in Form 3 you learn radioactivity, and one of the radioactive radiation is gamma ray. Okay, gamma ray is produced from unstable nucleus that decay. Okay, unstable nucleus decay, release the energy from the nucleus in the form of gamma ray. So the amount of energy in gamma ray is very high, the highest among all the 7 electromagnetic waves. Okay, so that is why gamma ray is very dangerous. Okay, gamma ray, the energy in gamma ray is so high that it can produce ion. That means it can ionize the air. Okay, if you pass through air, pass through anything, okay, go into your body, then it can it has ionizing power. Okay, ionizing effect. Okay, So it's very dangerous, so gamma ray is the most dangerous. Alright, so if you have any question, please ask. If no, then we will continue to the next part. Okay, next we want to look at application of electromagnetic wave. Okay, so type of wave. First, radio wave. Long distance radio communication, local radio, TV broadcasting, wireless communication, Bluetooth, Wi-Fi. I don't know what is ZigBee. Maybe you know what Z wave also. Actually, I also don't know what is Z wave, what is ZigBee. Okay, maybe you can go and Google. Okay, okay, but anyway, you at least you need to know like Bluetooth, Wi-Fi. Okay, is use the radio wave. That means the frequency and the wavelength is in the range of the radio wave. And then millimeter wave machine to scan body of passenger at airport. Okay, this is scan body of passenger. That means like they want to detect whether got metal. Okay, got metal or not. Okay, right. Okay, metal detector. And then microwave. Okay, international communication through the use of satellite. To communicate from ground to satellite, they need to use microwave. Why is it need to use microwave? Because microwave can penetrate through the atmosphere. Okay, can penetrate through the thick atmospheric, the thick atmosphere okay, can pass through and go to space. Microwave. Radio wave cannot. Radio wave when want to when go up, it will be reflected by the atmosphere and go down again. So radio wave cannot pass through the atmosphere and go to space. So when you want to communicate with satellite, must use microwave. Okay, mobile phone framework. Okay, mobile phone also got use microwave. Communication between electronic device, okay, Wi-Fi, Bluetooth, ZigBee, Z-Wave, okay, also got use microwave okay, also got use microwave. Detection of plane radar and speed track, okay, also use microwave. This one, the plane radar is like this. Okay, let's say got aeroplane, okay, got aeroplane. So this radar, how does it know that there is aeroplane? So this radar transmitter, it will transmit the microwave. The microwave will hit the body of the aeroplane and reflect back, and then they will detect and then it will detect and calculate how much time does it take for the wave, for the microwave to go to the aeroplane and reflect back. And from the time, they can calculate the distance of the aeroplane from the transmitter. Okay, they can calculate the distance of the aeroplane, then that means they can know where is the aeroplane Okay, they can find out where is the aeroplane, detect the aeroplane. This is how the radar. Okay, this is how the radar works. Alright. So the radar is like, the concept is the same like sonar. Okay, we got learn about sonar when we learn about reflection of wave. Okay, right now when we learn about reflection of wave, one of the application is sonar, where you can use sound wave to detect fish and other object under the sea. Okay, speed track. Speed track, that means by shooting the microwave, and the microwave hit the car and reflect back, they can calculate the speed of the car. So if the speed of the car is too fast, then it will automatically take picture of the car. Okay, it will take picture of the car. So this speed track or we know it as AES okay, AES. Okay, speed track, speed track. Okay, cooking using microwave oven. Okay, so how is it that we can cook by using microwave oven? So what the microwave oven do is the microwave oven produce microwave. Okay, it produce microwave and the microwave will go into the food. For example, let's say you want to cook a chicken. Inside the body of the chicken, you have water molecule and also fat molecule. Okay, fat or oil. Okay, fat or oil molecule. So what happens is the energy of the microwave will be absorbed by the fat molecule and water molecule. And after the water molecule and fat molecule absorb the energy, what will happen? The energy of water molecule will increase, and when energy of water molecule increase, what happens? The water molecule will vibrate. Okay, the water molecule will oscillate. Okay, vibrate faster. If vibrate faster, that means the kinetic energy of the water molecule is higher. And when the kinetic energy is higher, that means the temperature of the water molecule will increase. So that means the water molecule inside the chicken will become higher, become hot. Okay, the water molecule temperature will increase, the fat molecule temperature will increase and release heat. So the heat that is released from the water molecule and the fat molecule inside the body of the chicken will increase the temperature of the whole chicken. So it will cook the chicken. Okay, that is how it produces heat to cook the chicken. So basically, the microwave oven make the chicken cook itself. Okay, the chicken cook itself because the heat energy is produced by the water molecule and fat molecule inside the body of the chicken. Okay, the heat energy does not come from the microwave. The microwave oven only produce microwave. Energy of the microwave absorbed by the water molecule and fat molecule and become heat energy and cook the food. Okay, so that means if the food or anything that you put inside the microwave oven have no water molecule, have no fat molecule, then it cannot heat up. It will not become hot. Understand? Okay? But usually any food also have fat molecule and water molecule. Okay? Alright, next. Infrared ray. Okay, how do we use infrared ray? For cooking, oven, grill and toaster that use infrared. For example, the ceramic stove. The ceramic stove, you can see that it will have like a lot of LED lights. Okay, when you turn on, it will glow red color. Okay, glow red color. So those are actually LED or actually not LED lah. Okay, those are bulb. That infrared bulb. Okay, it can produce infrared ray. So the infrared ray can transfer heat energy very efficiently. Okay, very efficiently, very effectively. So the energy from the infrared ray, when absorbed, it will very easily turn into heat energy. Okay, so for cooking, infrared ray. So that means you don't need fire. That means you have the bulb that produce infrared ray, and then you can cook because the infrared ray, the energy of infrared ray when absorbed by object, it can increase the temperature of the object. Okay, for night vision, infrared camera and infrared binocular. So that means it's like when you watch movie that the soldier movie where the soldier at night they want to go and kill the enemy, and then they at night very dark they cannot see, and then they put on a goggle, and then after put on the goggle they can see the body heat of the enemy like that. So that is a night vision infrared camera. Okay, more or less like that okay, but not exactly Okay, next is drying paint on car. Okay, so when they want to dry the paint on car, they shine the infrared ray on the car, so the paint will dry up. Okay, so no need to put the car under the sun. they drive the car inside an enclosed room, okay, in a room, and then they shine the infrared ray on the car, and then the paint of the car will dry. Okay, treatment of muscle pain. Why is it it can treat muscle pain? Because heat. Okay, for example, after if you have cramp, muscle cramp, so you need to heat your muscle to make your muscle relax. So can use infrared ray. Remote control device for television and DVD player. Any remote control any remote control, your TV remote control, Astro remote control, the remote control for your aircon, whatever okay, all remote control. If you look at the front, you look in front of the remote control, you can see like there's a small red color bulb right now. Okay, there's a small red color bulb. So when you press your remote control, the red color bulb will produce infrared ray. You cannot see If you look at the bulb, you don't see the bulb produce any light because the light that is produced is infrared, and the frequency of infrared or the wavelength of infrared is too long, so our eye cannot detect. Okay. Next is visible light. Enable living things to see, photography, photosynthesis in green plant, laser light used in cutting of metal, measurement of length, and sending of information through optical fiber. Okay, we use visible light. Okay, this is all application of visible light. Next, ultraviolet ray. Okay, ultraviolet ray, we use ultraviolet ray to harden tooth filling material, determine authenticity of currency note. Okay, you go to shopping, you take out 100 ringgit paper money, 100 ringgit you give to the cashier. The cashier look at your face, feel like you look like a criminal, and then will take the money, don't trust you, then take the money and put under the ultraviolet ray, and then we'll see oh, shiny, so that means the money is real money like that. Okay, that is determine authenticity of currency note. Okay, next, treatment of jaundice in baby. Some baby, when they are born, after they are born, they may become yellow. Okay, the skin become yellow, so that is what we call jaundice. Okay, jaundice. So so put the baby in a room with ultraviolet ray, but not very strong ultraviolet ray okay, not strong ultraviolet ray, just under a light like that okay. So it can help to treat jaundice. Okay. Purification of drinking water, that means to kill the germ okay, to kill the bacteria and so on in the drinking water. Sterilizing surgical instrument and food, insect trap. Okay. Just now we say that ultraviolet ray have a lot of energy, it can kill the cell on our skin, right? So if it can kill cell, that means we can kill bacteria also we can kill germs, kill bacteria, kill microorganisms with the ultraviolet ray. So that's why we can use the UV, okay, ultraviolet ray to purify drinking water and to sterilize surgical instrument and food. Okay. Okay, so next, X-ray. X-ray, detect fracture or broken bone and examine internal organ. Checking or welding connection, baggage scanning at airport, determine authenticity of painting. Okay. So I think no need to explain right? You know how X-ray works. Okay, X-ray pass through the body. The part of the body that have flesh, okay, that means your muscle, the X-ray can easily pass through the muscle. So you see the part where you have muscle is a little bit white only, and then the bone is white color. The reason why the bone look like white color is because the bone actually block the X-ray. Okay, the X-ray cannot pass through the bone. So the film, okay, the X-ray film have chemical that is sensitive to X-ray. So when hit by X-ray, it will turn black color. Okay, turn black color. The more X-ray it detects, the darker the color will become. That's why you see this one. Okay, this area is black color because there's nothing that block the X-ray. So the X-ray directly hit this area, so the area become black color lah. But this one, okay, the area that a little bit white is, that means exposed to a little bit of X-ray, and then the bone is white color because it's not hit by X-ray lah. Okay, X-ray doesn't come into contact with that part of the film, so the film continue to be white color or transparent actually. Okay, so the last one, gamma ray. Gamma ray is very strong, have a lot of energy, so can kill cells very easily. So we can use to kill cancer cell in radiotherapy, sterilization of surgical and medical equipment in bulk. Used in food processing industry so that food can last longer. That means basically in food processing industry, what they do is, for example, there's a package, the food already put inside. Okay, food already put inside, but they want the food to last longer, so they shine the gamma ray. Okay, they make the gamma ray, they shoot the gamma ray, pass through the packaging, pass through the food, pass through the packaging. The gamma ray pass through the packaging, go inside and pass through the food, so can kill the bacteria inside the food, inside the packaging. Okay, so this can make food inside packaging to last longer. And it can also irradiate. That means you can use the gamma ray to shine on fruits like onions or potato to make it germinate. That means to make it sprout slower. Okay, we know that potato, ginger, onion, if you put for a long time, it will germinate. That means it will come out. It will grow shoot, right now. Okay, it will grow shoot, come out. Okay, so for industry, the agriculture, they want to export, let's say potato, export to other country. So the potato need to put inside a container and put on a ship, and need a long time to travel to that country, right now. Okay, need a long time to travel to another country. So what they do is they take the potato, onion, and so on. They shine the gamma ray onto the food. Okay, onto the potato, onto the ginger, onto the onion, and then it can delay the sprouting process. That means the ginger, the potato, it will not sprout so fast. Okay, then it can last longer lah. Okay, like that. Okay, exercise 1, number 1. Figure 5.71 show an electromagnetic spectrum. What are wave A, B, and C? Okay, so you see radio wave over here. So A here must be gamma ray lah. And then B is between X-ray and visible light. So B must be ultraviolet ray. C is between infrared and radio wave, so it must be microwave. Okay, next, arrange the electromagnetic wave below according to the order of increasing frequency. Okay, so we have infrared, X-ray, microwave, gamma ray, radio wave. So increasing frequency, so that means from low frequency to high frequency. Okay, low frequency, that means long wavelength lah. So radio wave first. Okay, radio wave, and then after that is microwave. After that is infrared ray. After that will be X-ray. and gamma ray. Okay. Next, number 3. Okay, in the air, blue light. Okay, blue light with wavelength of 420 nanometer move at the speed of. Okay, wait a minute. What is the wavelength of the blue light in the liquid? Okay. Blue light with wavelength. Okay. So blue light with wavelength of 420 nanometer move at the speed of 3 times 10 power by 8 meter per second. So this is the speed of light. The speed of blue light reduced to 2.25 times 10 power by 8 meter per second when passing through a liquid. What is the wavelength of the blue light in the liquid? Okay, so you see in the liquid, okay, this one is the air. This one is in liquid. So the blue light go from air into liquid. So the blue light here have wavelength 420 nanometer. Okay, the speed is 3 times 10 power by 8 meter per second. When go into the liquid, what happen is it says that the speed become 2.25 times 10 power by 8 meter per second. Okay, so what is the wavelength? So the wavelength is definitely going to change because the speed decrease, right? And the frequency, what happened to the frequency? If this is frequency 1 in the air, this is frequency 2 in the liquid, what happened is the frequency is the same. The frequency doesn't change. Why the frequency doesn't change? Because remember, for wave, the frequency of the wave depend on the source, depend on the wave source. That means depend on the thing that produce the wave. If the thing that produce the wave have high frequency, then the frequency of the wave will be high. If the thing that produce the wave oscillate at lower frequency, then the frequency of the wave will be lower. Okay, so the frequency of wave depend on the frequency of the wave source. So don't care whether the wave go in air or liquid or anything, the frequency is not going to change. Okay, the frequency is not going to change. All right. So from C equals to F lambda, we use C lah. Okay, if you want to use C equal F lambda or you want to use V equal F lambda, also never mind. Okay, this is actually not important because C is the speed of light, V is the wave speed. Speed of light is also wave speed, is the same thing. So you want to use V equal F lambda also can, you want to use C equal F lambda also can. Okay, so frequency equals to speed over the wavelength. Alright, so this frequency equals to speed over the wavelength. Speed over wavelength. Or you want to use C also can, no problem. Okay, 1, 2. Alright. Okay, so wave speed 1. We take it 1, okay, inside the air. So the wave speed is 3 times 10 power by 8. After that is the wavelength inside the wavelength inside the air, 420 nanometer. So 420. Okay, I changed into Okay, no need to change also, never mind, because both sides also nano. Okay, this on the left is on the left wavelength nano, on the right later on we will also get nano. Okay, and then this V2 is 2.25 times 10 power by 8. So what will be the wavelength inside the liquid? Okay, this will be equal to Okay, so you will get 315 nanometer. Okay, 315 nanometer. So that will be the wavelength of the blue light in the liquid. Okay, in the liquid. Alright. Okay, next question, number 4. This is essay question. Okay, figure 10 show a system of communication which involve direct transmission of electromagnetic wave signal from a transmitting station to a receiving station. The distance between the two distant stations and the shape of the earth cause the receiving station to be unable to receive clear signal directly from the transmitter. You are required to give several proposals to improve the quality of transmission of signal. Okay, so you see, why is it that the transmitting station and the receiving station, that means the wave is difficult to go to the receiving station because of the shape of the earth lah. Okay, and another fact is because electromagnetic wave, for example, light is also electromagnetic wave, right? Light travel in a straight line, right now. If light travel in a straight line, that means all other electromagnetic wave, from radio wave until gamma ray, all of them also propagate in a straight line. Okay, all of them propagate in a straight line. So if that is the case, that means you just see if from here transmit like this, you see the wave go in this direction. It cannot be received by the receiving station, right or not? Okay, cannot. Okay, cannot reach the receiving station. It's blocked by the earth itself. Okay, blocked by the earth. So what is it that we can do? Okay, explain your proposal based on the following aspect. Okay, A, type of wave broadcast. Okay, so this is communication. Communication. So for communication, what is it that we use? For your information, just now we discussed a lot of application for the different type of electromagnetic wave right now. Okay, we discussed a lot of different type, a lot of application for different type of electromagnetic wave. You must know at least a few. Every type of wave you must know at least like 2 or 3 application. Okay, you must know at least 2 or 3. At least like you have an impression. You have an impression when you look at application, you can think, oh, I think this is microwave or what wave like that. Okay. Alright, so type of wave broadcast, we need to use radio wave lah. Okay, radio wave. Okay, I answer part by part. Okay, so we use radio wave. Okay, radio wave. Type of wave broadcast, radio wave. Okay, so why is it that we need to use radio wave? Longer wavelength, able to propagate longer distance. Okay, like that. That is the reason why we use radio wave. Longer wavelength, able to propagate longer distance. Okay, B, frequency of wave. Okay, so what is the frequency of wave that we use? We need to use low frequency. Low frequency. Why we need to use low frequency? So that it is longer wavelength. Okay, so when it's longer wavelength, able to diffract, pass through obstacle. Okay, that means it can diffract around obstacle, around object lah, that block it, so it can go longer distance. Okay. Okay, so that is the reason why we want to use low wavelength, so that the wavelength and low frequency, so that the wavelength is longer. C, method which enable the wave to propagate through a further distance. Okay, so how is it that we can make the wave propagate through further distance? Okay, we can say we use satellite. Okay, use satellite. Okay, relay the signal to another side of Earth. Okay, because blocked by planet Earth, right? Okay, blocked by planet Earth. So we use satellite to relay the signal to another side of Earth. That means like this: if you use satellite, because you see how blocked by Earth, right? So if you use a satellite here, okay, here you put satellite. That means the signal go to the satellite, and the satellite can relay the signal to the receiving station, like that. Okay. The location of transmitter and receiver. Okay, so the location at higher altitude. That means put at a high place, like on top of the mountain or something. Okay, you can say at mountain, on top of the hill, on top of mountain also can. Okay, look, same as if you say location at higher altitude. Okay, so to avoid obstacle near the ground. Okay, on the ground there are a lot of obstacles, trees, buildings, small hill, and so on. So if you put the transmitter and receiver at a higher place, then it won't be blocked by all of these things. Okay. Alright, refraction of light. Okay, refraction of light. So light is also a wave, like what we learned previously in electromagnetic wave. Light that we are talking about here is referring to visible light, light that we can see. Okay, visible light, light that we can see. Okay, light that we can see. Okay, so we want to look at refraction of light. So what is refraction of light? Refraction of light is change in direction of light due to change in velocity of light when traveling through medium of different optical density. Okay, so we already got learned about refraction of wave. Okay, we already got learned about refraction of wave. In refraction of wave, we learned about refraction of 3 different types of wave: water wave, sound wave, and light. Right? So we learned that what is it that causes refraction of water wave? When because of the different depth of the water. So when the water wave go from deep to shallow, then the wave speed will slow down. Sound wave, it can change due to temperature, due to density of the medium, the speed of the wave can change. And for light, the speed of the wave change because of different optical density. So optical density is not the same as density. Density is mass per unit volume. Okay, density is mass per unit volume. This is density. Optical density is not the same as density. Okay, it's not the same as density. For example, density of oil is lower than water, but optical density of oil is higher than water. Okay, I repeat, density of oil is lower than water, but optical density is higher than water. So this shows that density, optical density is actually not the same as density. So the reason why we give the name optical density is basically if the medium, okay, if the medium is able to slow down the light more, okay, can make the light slow down more, then that means the density, that means the optical density will be higher. Okay, so basically if the light travel to a medium of higher optical density, then the speed of light will decrease. Okay, from low optical density to high optical density, the speed of light will decrease. From high optical density to low optical density, then the speed of light will increase. Okay, the opposite. Alright. So let's look at this. Okay, this diagram. Okay, so you see we have a glass block. Okay, we have a glass block, and then we have air. So just think logically, we can imagine that the glass block will have a higher optical density compared to air. Air have lower optical density, glass block have higher optical density. Okay, air, low optical density. Glass, high optical density. Okay, so what happened is when the light, okay, so this light that going towards the glass, we call it the incident ray. When we learn about wave, we learn that it is called incident wave. Here, you want to call it incident wave also can, but because it's light, so we use the word ray. Okay, so we just replace wave with the word ray. Okay, so incident wave become incident ray. Okay, now, so the point where the light ray or the wave enter, okay, into another medium, okay, is what we call the point of incidence. So this is actually the same as what we learned in wave. Same. Okay, and the normal is the line that is perpendicular with the boundary between the two medium. Okay, normal. Okay, so and this angle, this is the incident angle. Okay, I incident angle. So this incident angle is measured from normal. Okay, from normal to the incident ray. That is the incident angle. And then when the light go into the glass, okay, it go into higher optical density, so the speed of light will decrease. The light becomes slow, and then it will refract towards the normal, or it will bend towards normal. Okay, so if it bend towards normal, so we have R, which is the refracted angle. to be smaller than the incident angle. Okay? And here, when the light want to come out from the glass block back into the air, so what happens is the speed of light become faster. When it go into from glass go into air, that means the light go from high optical density to low optical density, so the speed of light increase. Actually, it go back to same speed as here lah, the incident ray. This we call this emergent ray lah. Emergent, we call it emerge, come out, emerge. Emerge, that means like come out from something, emerge. Okay, emergent ray. So this emergent ray have the same speed as the incident ray, this one here. Okay, because it's in the same medium. Both also air. Okay, both also air. So that means both of them will have the same speed. So when go from high optical density to low optical density, so the speed of the light will increase and it will refract away from normal. Okay, refract away from normal. So here the refracted ray will be bigger than the incident ray lah. So this incident ray is small, this refracted ray is bigger. Okay. Okay, so let's just go through this in the note. Okay, light ray travel from medium or low optical density to medium or high optical density. So this is explaining what is happening here lah. Okay, what is happening here? Speed of light decrease. Light ray bend towards normal. Angle of refraction smaller than angle of incident. So this is when this is explanation for incident ray. The light go from air to glass block. Okay, this one. Light ray travel from medium or high optical density to medium or low optical density. Speed of light increase. Light ray bend away from normal. Angle of refraction larger than angle of incident. So this explain where the light go from the glass back into the air. Okay. So this is a little bit lah. Okay, we discussed a little bit about refraction of light. Until here, today we will stop here and we will continue tomorrow. Okay, if you have anything that you cannot attend tomorrow, then please let me know so that I can arrange another time lah. Okay, so all right.